Hello, everyone, and welcome to this talk. My name is Shadi Ashnai, and I'll be talking about video creation today. Majority of this talk is not functionality that is going to be coming in the upcoming 14.2 version, but I think it's a great packaging of capabilities that have been developed in the past versions of the Wolfram language. And I'm going to be showing examples and focusing on how valuable video creation within the Wolfram language can be to anyone who's doing actually any project from various domains and areas of the Wolfram language itself. So as I said, I'll be talking about techniques, but with some focus on examples as well. We'll talk about capturing from screens and connected webcams, assembling from just pure 2D images, static images, touring around 2D and 3D images and graphics, folding, nesting from programs, animations, manipulates. And last but not least, I'll talk about all the small but really, really useful editing and composition capabilities that allows everyone to package their potentially small snippets of videos into one impressive larger video. Examples are going to be throughout the talk just to make sure it keeps the excitement of this talk high as well. Okay, so let's begin. Simplest functions are simplest video creation functions are capturing from screens or from the webcams. We have two functions that would allow for capturing from webcams. So that's me again here talking. I can start recording, stop recording, a video object comes back, just like that. Similarly, I can capture from my screen. That's a great preview that shows this is a wrong screen. So I'll go ahead and say, let me actually pause or stop this, cancel this, and then do another one with screen 2. This is the screen I'm sharing right now. So I'm capturing that. Similarly, I can start and stop. Let me go ahead and close this one too. There are programmatic ways that can allow doing the same things, recording from a screen or recording from any connected device. And then through functions, video stop, video record, pause, and things like that, one can programmatically move towards whatever kind of recording that needs to happen. These could obviously be conditional. If something happens, stop the stream and things like that. As the stream happens, I can in fact do any other computation that I want. That's why stopping, pausing, reacting on condition can still happen. So that's, I think, a part of the lower left corner of my screen that got captured as I let this capture run. So let's move on to some other simple, basic, but useful video creation techniques. Constant video is one of the newer additions, but probably the most simplest one. I pass one image to constant video, and 1 second or any second, I can add a second argument of durations like 5 seconds or a quantity 5 seconds there and get as long as I want of that video. Slideshow video basically has a default duration. This one by default creates a 5 seconds. Similarly, we can specify how long of a video we want, but basically divides that linearly between the images that are passed to slideshow video. However, one can specify explicit durations for the different frames that are being displayed there. The third function that we have that would take us from a series of images to videos is frame list video. There we have a full list of frames, one by one, that need to be encoded into a video object. Here, for instance, I have an example that I'm nesting an operation like image restyle on that fish image. I do it 2 times, so I get 3 images, including the initial seed. If I repeat that so many times, 50 times, I get 51 images back, and I'll go in and plop my list into the function frame list video, and I get exactly all of those 51 frames Again, here we have some default frame rates, all of those, or I explicitly set 15 frame rates, so roughly 3 seconds of video comes back. These parameters all can be adjusted. In the keynote speech yesterday, Stephen showed the creation of the map of the Roman Empire for the times that we have a polygon for. And here I'm creating a time series, for instance, from that geo variant of Roman Empire and get the polygons back. Then I go ahead and use slideshow video. I could have probably also used frame list video. And then I run something like time series map, create geographics of the polygons that are constructed with whatever function. And then I go ahead and label my plots with a label that says what year that map is extracted from. With a duration of 20 seconds or whatever is desirable. This is basically showing the year on the top, or could be on a corner or whatever, and then showing how the map evolves over basically centuries. I would like to, in order to save time and also give you some potential excitement to dig through, I'm giving links to examples that people have used video creation capabilities. Very recently, tracking Hurricane Helene, Arnaud from Wolfram Research basically got a source of images that was showing satellite images of the hurricane reaching the US. And then somewhere at the end of his exploration, he is basically passing those frames that are being downloaded, extracted from the website into one video. And here is the amazing video showing how the hurricane is approaching the US. Another example that caught my eye very recently, and I was pleased to see again video is being used, is showing off the power of ND solve. So here PDEs are being set up and solved and all of that. And at the very end, again, in the core of this function, there is a frame list video that puts all of those generated frames into one video showing how basically the equations were solved. So we'll move on from assembling images to touring 2D and 3D images. This is also not a new function, but has evolved quite a bit over the few versions that it has been released. One of the uses of touring large images or touring images is when the image is really large and it's hard to see details of the images. So here I have a simple example where I specify positions, width, and I think that's it, and the width is fixed. So this one is basically panning and zooming on that image, going from one side of an image to another, and then, oh, actually, I'm panning and zooming because the width is changing. I didn't see that in my first look. Okay, so the position changes from that XY coordinate to this one, and the width goes from 3000 to 200, which is showing that zooming, and then the panning is the position change. Fun other kinds of tours. Oops, the jump is there. Wrong key. Another fun other tour, we have specified this spiral path. And then I think this was one of the examples on previous Stephen blog posts. If I highlight the path on the image, this is how we are spiraling. And then tour video of the image, path gives us an image that basically follows the path on the image. Same function, tour video, is also enriched with geographics. So I can just pass geographics here and say I want to go from one city to another. And then here is a linear travel from one city to another. As I was just creating this, I was thinking something like travel direction would be interesting as well. So instead of just linearly going like a flight direction from one city to another, I have computed the travel directions, and I go from one city to the next one as if I'm driving on the map. More of these are coming. We have been focused quite a bit on video analysis, but I think video creation could get another boost and more functionality along those lines. 3D tours got added more recently compared to 2D tours. Simple rotations around 3D graphics and regions. I should have probably pre-computed some of these. This is, okay, so while this one is running, I'll run the next one as well so that we can talk about it. By default, Tour 3D video is basically rotating around an object that is passed. It has all its, as usual, beautiful defaults on how big of a radius I need to choose to rotate around the object so that I see more of it. However, similarly to what we said for tour video, we can specify a specific path. Here we have a position defined as a function of t, and then I'm showing the path that we're taking around our castle using parametric plot 3D and show. And then here I'm doing a tour around my geometry G using that position function that was specified. And one thing that's probably nice to mention right now as we're waiting is that we have upgraded most of our progress monitors to show basically a preview of what's happening in the video generation. So that has become really easy to spot potential mistakes and pause the creation of the videos. Okay, we talked about 3D tours. There are some very, very nice examples on community and elsewhere showing the power of tour videos. One of the most recent ones are from Vitaly, director of community, and he was basically showing this hand twirling of the 3D object. There, I think, again, in the core of the function, he has this beautiful manipulate created, and then he's passing that over to Tor 3D video to create this nice animation. Illuminating proteins were one of the earlier examples we had last year with Annika Patel, one of our summer interns. An amazing work, which again is this post is a little more extensively explaining what's happening with lighting and what's happening with positioning and all of that, cameras. And then towards the end, this one predates Tour 3D video. I believe Annika was basically creating all of the things that were needed for Tour 3D video in this post by other ways of creating. But towards the end, for instance, this is another beautiful example that shows touring around. And as you see, she was using animation video with all the parameters controlling the view vertical and so forth. So again, these functions are there if something that is default is not working. Animation video, which we get to next, or alike functions would be really useful in showing, enabling whatever types of creations that is necessary for your applications. Here is another example that I'll, for the sake of time, leave it for you to explore. And that takes us to creating videos from programs. So video and Reap video are the newest of the video creation families. Just like sow and reap, where some expressions can be sown from whatever computation that is happening and then reaped into the final computation. We have added these two functions, sow video and reap video. Sow video actually has an argument that can say, repeat this frame that was sown so many times or for such and such duration. Let me actually run this and explain. Actually, this was pretty fast. So what's happening here, I'm using a construct like nest while list. And I'm after tinning that image, I'm pruning the image one pixel at a time, which is that list of one. And I will sow all of those frames, but I also ask nest while video to wait or pause, finish, whenever my frames, or as long as my frames are unequal, comparing two frames at a time. And then whatever got sown gets reaped into reap video. So here we can see nest while list, which is a very powerful nested iterative recursive construct, can be used in order to create such an animation. And all we needed was just to make sure we saw all the frames that are created and then reap them at the end into a video. Sewing on a condition is also pretty powerful. Here I have a video of a person practicing yoga. And what I'm doing is I'm saying, if you identify a face in that video, sew the video, so the video frame, otherwise drop it. And then all the sewn videos get passed to reap video. And here I'm getting a smaller chunk of the original video. Only frames are reaped or put into that resulting video if a face was detected. Another newer function is a fold operation. So basically, we get video frames, individual video frames, and fold whatever operation, just like fold list, on the frames of the video. This first example I have is showing basically a motion blur, where I'm going from a completely static, unblended frame into something that keeps blending the new frame on top of the previous frames, giving me that kind of a motion blur. Another neat example we had was a batter here. And in that motion, in a construct like remove background and compose, oh, actually, I had it already up there. We basically remove all the background and compose whatever foreground that remains from that on top of each other to get such a neat effect. And just because this one was half evaluated yesterday in the keynote, I put it here. That's another exactly the same code as we had for the baseball bat, but with the butterfly. One other sneak peek that is not yet released, fold pair, we realized was another really powerful functional construct that we had in the system. And it's very useful in helping us keeping states. So in cases like tracking bees or tracking ants or stabilization or anything that needs to keep some kind of a state, something like that fold pair is really useful. So even though we didn't release it as a system function, I think this is a very useful construct. So I'm demoing it. We've put it under the video context, but we're still thinking about if the design makes sense or if all the other constructs we have are enough. What I'm doing here, I'm starting from an initial set of points, which gets passed to my function f. And then here with something like image feature track, I'm passing the current frame and previous set of points. And then I specify whatever constraints, like I don't want my points to move beyond 15 pixels or whatever. And then with this kind of a function f, where we have the new frame coming in as well as the state being the new set of tracked frames, I pass the function to this video backtick video frame fold pair. And then I pass the video object to it as well. I get the first out of the function in order to get the new set of points that get passed to the next frame. And I say I want 2 frames at a time, shifting 1 frame at a time. That number of frames and offset is a very common set of parameters that we have in some of our other functions as well. So I start from the initial set of points. And as you see, each point is being tracked using our function max image feature track. As you have hopefully seen the image and audio and video analysis talk, there is tracking coming built into version 14.2, but I won't go into details of that for this specific talk. You've already seen a glimpse of creating videos from animations. I'll go through simple examples like this one where I have a function that transforms an image. If I animate that function, this is an animation with a control that I can move back and forth. The exact same piece of code, if I replace animate with animation video, I will pass this image I'll actually replace the S, not the X. And this one creates a video instead of an animate or manipulate object, and basically creates the same effect, but put it into a video object. Another example I have here is evolution of a cellular automaton that is being past how many steps I would like to animate that. The I is basically the steps or iterations in the cellular automaton function. And here I'm basically putting that evolution into a video object. There are very many interesting things that can be animated, including over time. This is, for instance, using astrographics, one of the most recent developments in the Wolfram language. And then with astro reference frame, I'm giving it a time of the day, basically over 24 hours of the day. We're looking at the sky, and this is what we basically capture into another video. As I said, many other beautiful examples out there. Another work by our intern, Annika, was creating animation videos through interpolations. So I think this top GIF is showing really the essence of what's happening here. The positions here are being interpolated, but going through the rest of the post, she has interpolated sizes, positions, and whatnot as we go down the post. So this one, for instance, interpolates size going from really small scaled to the large final size that would like to be displayed. This one is another really interesting post. I'll leave it to you to explore later. And then I'll get to manipulates. This one also is one of the more recent creations or developments in Mathematica. Manipulates with one parameters are basically like animates. Here I have one variable. If I pass that to the new function in 14.1, manipulate video, I basically linearly, I have all of these evaluated, so I don't evaluate the rest of them. I linearly go from H, the hue parameter, going from 0 to 1. And that's no different from animation video, taking H from 0 to 1, basically going through different hues. However, one can specify in manipulate video how to control the parameter H or whatever parameter. So here I'm starting from 0 at time 1. I go to 0.5, pause for 2 seconds until time 3 at 0.5, and then continue to time 4 to the value 1 of hue. So that's a pause on cyan, and then continue to go forward. Manipulates with multiple videos would get more, with multiple variables would get more exciting. Do I increase H first, S next, then take H back, then take S back? Do I do simultaneously or what? And then manipulate video is a construct that I still think we can develop it further and further. That can help control all of that behavior of manipulate controls. So by default, controls are simultaneously updated. However, one can, similarly to what I showed above, specify how the controls should move. So here I'm doing the same behavior as I explained for H, increase, pause, increase. And then for size, the parameter S, size of the disk, I would increase it, then decrease it back to a smaller size. So that's the result of that control. There is a new option that is added both to manipulate and manipulate video called keyframe actions. One can, by default here, manipulate objects have bookmarks, and we can add to bookmarks. But if I pass a keyframes actions go to true, and I'll try to limit the time for this demo as well. Instead of add to bookmarks, you see add to keyframes. And keyframes are basically can be thought as timed bookmarks. So if I add to keyframes, give it a name or whatever, that basically shows up as that untitled keyframe. And one can specify keyframes programmatically. So if you have computed the placement and values for different controls, this is another way of specifying how keyframes should be specified. And then just like we had animate bookmarks, now we have animate keyframes, and this is basically doing that animation of keyframes. Manipulate video respects the keyframe options of the manipulate object, but also if you're passing your expression to manipulate video directly, then you can also pass your keyframe actions directly to manipulate video. So this is following that action that was specified. Borrowing from demonstrations, I here have an example, a simplified example of understanding 3D rotations. And I'll scroll down for the sake of time again to show how we have here specified all these keyframe actions, the change of the 3 parameters that are specified to basically help build intuition about rotation. So we rotate around that axis first, the second axis, then we move to the center, rotate around the center. And with that, I would like to invite everyone to check demonstration projects that you have submitted in the past or that have been interesting to you and build new experiments based on them. Because I really think this is a new way of building intuition and building new stories and experiments around all of those manipulates that have lived for almost 2 decades now in the language. I would like to show a few small tips and tricks about editing and composition, because a lot of the times that short video that was created using the functions I showed so far is not enough of an exciting creation and final production. So small things, here I'm showing a constant video of something, some text. It's very common to have something called title slides in between video snippets. We have a construct like grid video, another editing function that can take, here I have 4 videos and put them into a grid with some spacing and all of that. Here I create another grid of videos based on some cheerleading example. Then I join basically everything together. I have a title frame here, my toothbrush brushing video, another title frame, and then the cheerleading example. So here's basically the final product with 2 title frames between the grid videos that are generated. And then the cheerleading. Another nice thing that can be done, you can overlay something on top of the video that is created. So here I just overlaid a frame, but this one could be my screen capture, my webcam capture, so my head basically there. Another interesting thing, video combine. I can actually add a audio. This one is something I grabbed from Wolfram Tunes. And then this one now is my final production of the mini video that has a logo, has audio and everything. So that's about it. But before we go, I wanted to say that you create all of these. There is one small point to clarify. All of these generated videos are in files. They are basically in $Wolfram documents directory /video. If I look at that, I have a ton of them because I've just experimented with all of these functions a lot. If I create a video, actually I didn't, I have the final video already there. If I create a video, one can inspect information of that video to see where the file is located. Here it is in that default location. One can copy file, copy that file that is in whatever location into whatever desired location. Here I'm moving it to a folder under my desktop. It already is there. I can rewrite it with an override target option, or I can export the whole video. If you don't want to look at where this video is, you can basically just export it to that location as well. Another useful thing to know is that we have generated asset location for all of these video generation functions. If you want something like put this video next to my created notebook, just say notebook directory, or actually just change generated asset location, dollar generated asset location variable. And then the information will report that new location. So I went a little longer than I was hoping for. I'll see if there are questions in Q&A. In the meantime, the video computation overview is, I think, a great summary of what's currently available in video, all of video computation in the Wolfram language. I hope you've already attended Carlo and Ali's talk before mine. If not, the recordings will be available. I highly encourage you check that out as well. My talk you already watched. Our office hour is going to be in a few hours. And then we have the booth with exhibit hours as well, if you want to come ask questions or ideally give us some feedback as well. Thank you very much. With that, let's quickly check the questions. The notebook is already shared with the conference people. It's going to be on the talk. So check out for that as well. Can a 3D connection space mouse be used to control the track for the 3D video tour? Not yet. I don't think, or at least I haven't experimented with 3D mouses and Wolfram language. I think there are some people, perhaps the front-end people, have experimented with that as well. How hard is it to reproduce, Nick is asking, how hard is it to reproduce the workflow of video creation for 3 blue, 1 brown type of videos in Manim? We have actually experimented with a lot of things that Manim is doing. And I believe at this point, our video creation and editing capabilities is different from Manim for sure, but is not giving less of a functionality anyways. As far as, so you're also asking, is it possible to render arbitrary dynamic module into a video to have more interactivity in this process? I believe So Video and Reap Video would be helpful in that regard, but I haven't experimented with that. So good question. That intrigued me as something that potentially could be additional usefulness of video creation in the system. But as far as Manim goes, I want to get back to that question. As I said, we have extensively looked at what they have. The thing that is probably very different from what he's doing in the Manim library and what we have is that graphics primitives like disks and rectangles are parametrically defined so that one can grow or draw and fade and things like that. There are operations like that that are specifically allowed or possible with Manim graphics primitives that is not necessarily available in the Wolfram language. Apart from that, a lot of the editing and creation capabilities are, I would say, similar, on par. In some cases, our capabilities probably excel and go beyond what they have in there. That's at the end of the Q&A questions. Let me quickly look at the chat as well. Nothing in there. Thank you for joining me for this talk. I'll hope to see you in our office hours and exhibit booths. Thanks a lot.